Fun. All right, so this is Front-End Web Performance Clinic, and I have snappy animations. So what we're going to talk about is we're going to talk about why to make websites fast, what that even means. We're going to give a quick rundown on how browsers work and how to measure performance, and we're going to do some tips and tricks to optimize each stage. So my name is mherchel. That's my daughter Millie, and that's a picture of my puppy Dexter. Dexter is actually the dog that I love least because he recently destroyed one of my carpets, and so he's on my bad list. I work for a company called Lullabot. Lullabot does strategy, design, development, and now we also do support and maintenance. And there I am. And evidently, we work for a bunch of clients that you've probably heard of. Including things like we've done like the MSNBC website, Grammys, and a bunch of other cool things. So yeah, so there are a bunch of quotes on why to make your website fast. I'm just going to go through a couple of these right here. So something to keep in mind is that like when a lot of people think of performance, people start looking at like, PHP profiling with like XHProf or something, or they're looking at their MySQL slow query logs or something like that, and all that stuff is important. But just as important, if not more so, is the front end, because the vast majority of the rendering time to actually look at your website takes place in the browser. And if that's not going fast, people will abandon your site, which means that you're going to lose money, you're going to lose conversions. Mobile sites, most people are using mobile now, like that's the primary mode of, that's like the primary method of accessing the internet now. And if it takes over 5 seconds, sites that load quickly, that load in less than 5 seconds, earn up to twice as much ad revenue. There are statistics like this that can go on through like this whole time slot, but obviously we gotta move on. So I have a really cool animation here to talk about what fast is. You ready? Right there. So ta-da! Thanks for coming. So let's talk about what fast is. So when you hear about web performance, you hear about like a lot of different terms. You hear things like time to first byte, time to first meaningful paint, time to first interactive, speed index, and there's even like other ones that I don't consider quite as important. Let's talk about what these mean. So time to first byte is exactly what you think it is. It's like when you begin navigation and you get like that first header back from the server. Delays here can indicate backend performance issues, as I said before, like things like database issues, processing issues, PHP issues. You can cache. Like if your users are primarily anonymous, you can usually just kind of hide your problems with caching. That's what a lot of people do, and that's very similar between Drupal and WordPress. Drupal has very granular, effective caching, though, and it works. Yeah, Drupal's caching even helps out a whole bunch with authenticated users. Content delivery networks dramatically help. So a content delivery network is a service that you sign up for, and you can actually, when you sign up for it, you configure your DNS to point to their servers. And what they do is they access your website and will stage your website at servers that are closer to the user. So if my particular website is hosted in San Francisco, I can sign up for a content delivery network, and the content delivery network will copy my website and host it in places like Atlanta, in Chicago, in Los Angeles, in London. So if I'm over somewhere in Europe, when I access the website, instead of the bytes having to come all the way over from San Francisco, they come from London. And that dramatically speeds things up because obviously like the speed of light is only so fast. Time When you're looking at time to first byte, and I'm going to show some performance profiling, some real world performance profiling a little bit later. But when you're looking at this, you can see it right at the beginning here on the left-hand side. I can actually create a shadow maybe, and that tells you where your time to first byte is. I consider any time to first byte over a second or so kind of getting a little bit long, you know. If you're using an effective content delivery network, you can typically, and if you're on a fast connection, you can typically get your time to first byte like around 300 milliseconds or less. Time to first meaningful paint is when your content is actually visible and shows up on the page. So this is obviously important. Like everybody's gone to a website and like it's white for a while and things are spinning. The time to first meaningful paint marks the paint event that follows the most significant change to the layout. It's kind of a little ambiguous. You have to kind of look at your timeline. And so I'm profiling here the Drupal GovCon website, and you can kind of see to the left that there's the website actually paints a little bit earlier than what I'm pointing at, but the fonts don't render till right around 1500 milliseconds. And for this particular website, the content's not meaningful unless you can actually read it. You know, it's not like a picture-based website. So the time to first meaningful paint is right when those fonts appear. Time to interactive is when the load is finished and main thread work is done, and your website's consistently interactive. Have you ever gone to a website, especially like on a mobile device, and you can see everything and you're hitting the button and it's not working? And you're like, what the hell, you know, this is not working and it's still doing stuff, and you know, inevitably you start like tapping it harder because that's gonna make a difference, you know? There's actually like a term for that. It's like rage clicking, or like when you get. When that happens, that is when your website is not yet interactive. You know, through the nature of the way that browsers work with JavaScript, is that most of the work is done on just one thread, and if that one thread is busy, it will block any type of user input. A speed index kind of takes into account everything that we just talked about. It's the average time, how the page renders, and something that's to keep in mind is how it approaches visually complete. So even if you have a website, if you have like two websites and they both maybe have the time to first interactive at the same time and time to first meaningful paint, if one website kind of approaches visually complete a little bit quicker, it's going to have a higher speed index. And you can kind of see that through this this illustration right here. There's on the top row, the top website reaches visually complete quicker than the bottom website. And we'll have a higher speed index. And when you're looking at speed index, or when you're calculating speed index, you can run that through the audits tab within Chrome Developer Tools, and we're going to do that a little bit later. Let's talk about how browsers work, because it is very, very important to understand what your browser's doing a little bit behind the scenes so you can maybe make some optimizations. So the first thing we're going to talk about is actually downloading the information, right? So the first thing it's going to do is it's going to download the HTML. As it's downloading HTML, it actually starts parsing it even while it's downloading, which is kind of cool. And it starts prioritizing all the content in there, you know. So it starts looking at your style sheets. It starts looking at JavaScript files. It starts looking at images, and it starts saying this one's more important than this one. This one's more important than that one. And when it prioritizes, it uses highest, high, medium, and low. And the highest is basically just style sheets and your HTML. And then next you have anything like fonts and render blocking scripts that are in the head that do not have async or defer attributes, and any type of XML, HTTP requests, JSON files coming down. Those all have a high priority. Outside of that, you have things like with medium priority are script tags that appear in the footer that might have a defer attribute or something like that. And then low priority are images. Like everybody's seen like a website that renders, but the images are still coming in. But you can still use the website as the images are coming in, and that's a good thing. You want to use the website before all the images load, because sometimes those images can be very large. But the reason that those images come in last is because they are not render blocking and they are low priority. And when you're in developer tools, there's actually a column for a priority, and you can kind of see it in the middle right here. It's not visible by default, but you can like kind of right click on the column headers and add priority right there, and you can kind of see how some of this is looking right here. So you can see that some fonts have a highest priority and the images have lowest priority. The JavaScript has high priority. So it brings in all the files, and at that point, as it's bringing those in, it starts to parse and execute the JavaScript in style sheets. So everything, like in order to render the web page, it needs to parse all the CSS that is in the head of your web page, and it needs to execute all the JavaScript that's in your head that doesn't have an async or deferred attribute on it. If it's in the footer or if it's async or deferred, it will process it at the same time, or it will process it after. And only after it processes all this, it creates what's called the CSS object model. And the CSS object model is basically a big object that has like all your styles in there. So you can see things like right now we have the body set to a font size of 16 pixels, and that will cascade down to your other elements, your sub-elements under that, which may or may not have styles applied to those. At the same time it's doing that, it's looking at it's creating the document object model. And the document object model is basically a representation of the HTML, but it does things a little different. It will take into account things like what the JavaScript does, like if you have render blocking JavaScript that affected that, it will include that in there. But basically, it is a object that is representation of the HTML. It combines those. It combines the CSS object model and the document object model and creates what's called the render tree. And the render tree is actually like what will show up on your website. The render tree is a little bit different than the DOM because it will take stuff out of it that is like displayed none or something. In like CSS, you can display none. And it basically takes it out of the flow, it takes it out of the accessibility tree, it takes it out of everything, and because it's not in the render tree. And at that point, we know we have the CSS object model, we have the render tree, we know how stuff looks, so we can do the initial layout operation. And the layout operation is basically calculating how much space each thing takes and where it is in relation to each other. And you can think that's like pretty complicated, right? It's a very expensive operation. It uses the computer's, the CPU in the computer. Ideally, you only want to do layout once, but if you're doing animations, you might end up doing it a couple other times. This is a video of an early version of Firefox doing layout where it's like slowed down a whole bunch. And it's kind of interesting to watch this because it gives you an idea of like what your browser actually does when it's calculating and moving crap around your browser. It's like it's pretty complicated. So after we have layout, you have basically you're still not seeing anything. You have the paint operation, and the paint operation is basically filling in pixels, colors, images, all that type of stuff. That's a very expensive operation. Also, when you're painting, your browser can create multiple layers. Like you can imagine these kind of like Photoshop layers, where you can drag one layer on top of another and easily move one around. Your browser can do that. It can create multiple layers within your web page, and when it combines those and actually puts those out on the screen, that's called compositing. Compositing is done on the computer's GPU as opposed to CPU, so it's typically really cheap. It's a cheap operation. And one of the things to kind of think about this is when you are animating stuff, you want to ensure that the browser is compositing as opposed to painting or doing relayout. There's a couple things that you can do to really screw up, to really kind of screw this up. Because everybody's kind of seen those parallax websites, And have you ever been to a parallax website and you start scrolling and it starts stuttering and shit, and you're and your computer's fan comes on and stuff? It's doing that because it's doing paint operations on the scroll event, which is obviously a bad thing. So every time that scroll event fires, most of those are animating the background position property or something like that, and it forces a paint operation. And if you go back to that Photoshop analogy, imagine if everything was on one layer and you have to move something around, you have to repaint underneath of it, and that takes a lot of effort. That's what the browser's doing. So when you're doing animation, you wanna ensure that you're using compositing. I'm gonna talk a little bit about that in the future, because obviously I can say composite and you're what the hell does that even mean? So let's talk about measuring performance. I'm gonna do some live demos here. And does anybody know if my session is 45 minutes long or 50 minutes long? Or when does it end? 9:50. Should look at my... So this session usually goes pretty long, so I gotta kind of probably go a little faster here. Let me see. We're at 9:20, so we got 30 minutes. I also want to call out all my cool illustrations. I didn't actually do the jet engine illustration, but I kind of labeled things with web stuff, and I think that's kind of neat. Anyway.
Good job.
You're welcome. Yeah.
Great.
Yeah. So demo, right? So we're gonna do Audits tab. Does anybody have a particular website that's might be a little slow that we want to use? If not, I can pick one. So when I do performance audits within Chrome Developer Tools, I'm going to do some basic things. But one thing that I really want to highlight here is that I'm going to open up a guest window. And the reason that I open up a guest window is because it won't load any of the browser extensions, because when you are doing performance profiling, it will actually profile their browser extensions too, which can have a negative impact on the performance or a positive impact on performance. There are plenty of browser extensions that do things like block ads and disable tracking that actually make your website faster. So I want to pick on a website. So I'm just going to... What's that? Is the Somerville News, is that a...
Let's say one here is the Chattanooga Times Free Press.
There it is.
Yeah.
Times Free Press. Ooh, this looks nice and slow. See, it flashed once and then came out again and did a layout there. Right. So what I'm going to do is I'm going to open up Chrome. Oh, look, it's still spinning. Yeah, this is going to be a nice slow one here. So I'm going to open up Chrome Developer Tools. I'm going to go to the Audits tab, and what I'm going to do is I'm going to ensure that performance is checked, and I'm going to select no throttling. When you're typically auditing that type of stuff, you also want to audit against 3G speeds, and I also want to kind of talk a little bit about that. When you simulate 3G, you're also simulating a slower CPU, and that's super important because I'm using kind of a modern MacBook Pro. I think a lot of web developers have more modern machines, but a lot of people that are using your website are not. They're using these old Windows Millennium machines from 1972 and stuff, and they might be on a really slow internet connection. So what I'm going to do is I'm going to hit Run Audits here. And this is going to take a second, and I'm going to look for my water.
Is it right here?
Yeah, it totally is. Thank you for bearing with me here. So newspaper websites are always kind of interesting because they tend to do stuff really wrong, and the reason is because they don't have a lot of money. They're dependent on ad revenue, so they try to like throw in like every type of tracker ever in there. And this is horrible. So this is like an example of like really bad. Usually they're not that bad. So we can see like I'm gonna command plus this so you can see a little bit better here. So time to interactive 15 seconds. Geez, that's like pretty ridiculous. So what I'm gonna do right here is I'm gonna hit this view trace button. It's gonna take me over to performance tab and it's gonna load this profile. And so the first thing that we can see right here is that our time to first byte is a second, which to me is like is 1.2 seconds. So that's bad, and it's really bad since this is a Chattanooga website. We're in Chattanooga. You'd think that they could just like plug in their gigabit Ethernet like home and just like have something faster than this. Most newspapers are also like owned by conglomerates, and they probably all host their websites on like some like old like Windows NT server somewhere. So they're losing a second right off the bat right here, and we can start scrubbing the timeline right here, and we can see. So the first thing that's happening is we see a layout operation, and then it disappears. So that's kind of interesting right here. We could probably take a look at this a little bit closer. So right around here. So we can like start looking at this network right here, and we're bringing in a picture. We're bringing in this JavaScript file, which takes like 5 seconds to bring in. Some analytics, a bunch of stuff are coming down, but let's kind of take a look down here at the main thread here. So you can see that this layout, so right around, where is this, right around like 3 seconds. So these layouts right here are what's causing the refresh, but I wonder like what's deleting it. I'm guessing whatever this is right here. So I clicked on the file, and I'm going to click on this like little pretty print thing down here, and you can it'll actually kind of format it nicely. And of course this is all uglified and minified. I'm guessing there's something in here that's rehydrating the DOM. Like a lot of times websites will do like server-side rendering, but then they'll kind of delete everything and rehydrate it with JavaScript rendering. Anyway, so I don't want to kind of dwell on this because we don't have a heck of a lot of time. So what we can see right here is that we see like the first meaningful paint is right around 2 seconds right here, and after that, if we get up here, you can kind of see that there's a whole bunch of JavaScript running, and then right around 17 seconds or so is when we get the time to first interactive. So that's pretty bad. There's a whole bunch of third-party scripts here, and we can look at these. And we can look at these a little bit later, but if you go to the network tab and you go to JavaScript right here, you can see like there's 724 requests, HTTP requests, which is like ridiculously high. 173 of them are JavaScript files, and it looks like out of these uncompressed, they're sending almost 9 megabytes of JavaScript. Right? That's pretty bad. I don't know. Like, all right, for an example, like what Google recommends to send with JavaScript is something like around 250K max, you know, and they're sending 9 megabytes. And we can sort this by size, and we could probably see something large come in. No, like, so we see this one as API.circular hub is a 0.5 megabyte. I don't know. Let's talk about optimizations. Using less bandwidth is number one. Limit the use of large images. Using responsive images. Not Google, but Drupal out of the box ships with a responsive image module. It's a little bit kind of a pain in the butt to use. You have to set up breakpoints, not within your style sheets, but within Drupal. And what the responsive image module will do is it will serve different images for different screen sizes. And this is important because if I'm on my phone, I do not want like a large 4K image being served to me. I want something that's going to come up a little bit quicker, that I don't need to very high detail. You want to limit network requests. I think that before we were looking at around 700 network requests. Especially if you're using HTTP2. So HTTP2, if you're not aware, is kind of a newish protocol, and what it does is it can basically stream, slipstream your request into like one TCP IP stream, so it's not like doing like multiple requests or like a handshake for every single request. That can take a little bit of time. Let's go through here. What I'm doing right here is I'm sorting. This is an old version of lullabot.com right here, and this is something that I just kind of wanted to point out, that it kind of happens to everybody. It happens to us. Right here, there's this image that was a hero for an article, and it wasn't important for the website. It was just a hero, and it was a megabyte. This image, which is like very small on our website, was a megabyte. You know, so there's a couple of ways that you can tackle this. Of course, this is on an old version of our website when it was decoupled. It was a React front end and a Drupal 7 back end. And even though we were using things like image styles, it was still it didn't reduce the quality of the image. So that's something to keep in mind. Another thing that when you're where am I going at here? I'm having like a brain fart. I'm just going to move on. So the purple pattern you might have heard if you're using Gatsby. Has anybody participated in the Gatsby training yesterday? So there's a couple people. So purple pattern stands for push, render, precache, and lazy load. And basically at its core, what the purple pattern does is it basically pushes down your critical assets. It can do that through either HTTP2 server push, which basically when you request your initial document, it sends down critical files at the same time. Or you can do, resource hints. I'm going to talk about resource hints later. Resource hints are basically when you put like a little hint in the head of your HTML saying download this file immediately. And so it pushes down the critical files, it renders the page, pre-cache the remaining routes. So like anything that's in the viewport or that looks like you might be clicked on, it will actually reach out, download those, and pre-cache it. And then as the lazy load part is when you as you scroll down, it will as the links enter the viewport, it will reach out, grab those endpoints, grab those pages, and then cache them for you. And the end result is when you actually click on something, the HTML is actually pre-cached, so it renders immediately. And that's one of the reasons why websites why systems like Gatsby are amazingly quick, is because once you get that initial page load, which is pretty quick too because it's static, once you click on things, everything's cached. You basically have the whole thing on your computer. and you don't have to worry about reaching out to the server to download it. This is kind of an example of what not to do, although we just kind of looked at one. This is from USA Today. USA Today is kind of funny because there was like a little bit of a, I don't know, like a little bit of noise on the internet when like Europe passed the whole GPDR things, which basically means you can't track. USA Today, if you reach out to it over in Europe, it loads like really quickly. It just loads like HTML, some images. It loads what you want on a website. They don't do any tracking. They don't do any third-party stuff or things like that. But if you go to it and you're coming from a United States IP address, it loads like, what am I looking at? Like almost like 1,200 requests, like amazing amount of ads, a whole bunch of data, tracking, and everything. It's pretty bad. I talked a little bit about resource hints earlier. So resource hints look a little bit like when you're referencing CSS files. So basically there's a link rel preload, there's a link rel DNS prefetch, and there's also I think just like a regular prefetch right here. And the reason that these are important is because sometimes your browser has to go through a couple different steps to discover, like it has to go through a couple steps to discover what it needs, you know? An example of this is fonts. Like, this is the classic example. So say we're hosting our own custom web fonts, which is a very common thing to do, and it's a good thing to do. In order for the browser to know it needs to download the fonts, it has to, like, number one, it has to, of course, download the HTML, it has to download CSS, has to do, like, the whole, like, render tree CSS object model stuff where it actually reconciles the CSS with the DOM, and at that point, it looks in your CSS and it says, I need to download these files. And so that's why in a lot of cases you'll go to web pages and the web pages will render, but there's no text, and then the text will pop in because, and that's because the fonts are being downloaded when you're seeing that, are not yet downloaded. So you can solve that kind of just by adding let me show you some examples of this. You can see at the top right up here, I'm adding fonts. This is, I think, Pantheon. Yeah, this is Pantheon's website that we worked on last year. And I did a number of front-end performance optimizations as we were kind of getting ready to do like some redesigning and stuff. And some of the things that helped out the most were implementing these preloading of the fonts and preloading of the images that were in the hero. When we this is a screenshot of our of the head of Lullabot's previous site, which was, as I said, was a decoupled React site. And so what the site, we would load the JavaScript in the footer, and the site would also do the whole thing where it would be server side rendered, but then it would rehydrate everything. But our JavaScript bundle was pretty large. It was like something like a megabyte or something like that, which is, in my opinion, pretty ridiculous. So what we did was I implemented a preload for that in the header, and at that point it initiated the downloading of that JavaScript immediately as opposed to waiting, and that dramatically like sped things up by like over a second. We also pre-connected to other domains, and what pre-connect does is it like you know, your website is of course like a bunch of different assets that are primarily hosted on one domain, but some assets come from other domains, right? But in order to reach out to those other domains, you have to number one, you have to do like a DNS lookup. Your browser has to figure out what IP address it needs to reach out to, and then assuming that the website is using HTTPS, it has to do a certificate request and validate the certificate and all that takes time. So if you do a pre-connect, it'll actually pre-connect and validate the certificate, do all the certificate stuff, do the DNS stuff, and then by the time your browser needs to reach out to grab whatever assets from that domain name, it can do so without waiting. So here's a couple examples, so you can see, and once again, this is an early version of our website. You can see that, we have like a DNS lookup for like 152 milliseconds, and then a connection time, and then SSL time, and all that kind of adds up to like around 400 milliseconds there. It was, that's noticeable right there, and that's like maybe our API, or no, this is our assets, I think, right here. When you do a pre-connect, it basically takes that down to nothing, and that saves like almost a half a second right there from just doing the pre-connect. So that's pretty cool. So once again, this is kind of all together right here. You're going to see like once again, I have the fonts at the top, and you're going to see like I have some images there, and you're probably thinking to yourself, why are you doing resource hints for the images? And images should be images are low priority. You don't need them to render your web page. And the reason I'm doing it in this particular case is because this is a hero image, and the hero image is referenced through the background image CSS property. And that is kind of, that has like the same chain, like that has like the same problems that the fonts have, where the browser has to reach out, has to get the style sheet, has to reconcile it with the DOM, and then figure out what image it needs, and then it has to download it. And since that was in the hero area and it was visible immediately, it was kind of noticeable when the hero would pop in, So I added it here, and you can see like to the right up here, there's this media attribute up here, and that's kind of very similar to your media query attributes if you ever write CSS media queries. And so it will only download the correct image for the correct screen size. So resource hints, if there's one thing that I would like you to come out of this talk with, is like resource hints. You can start using these right away. It speeds things up, sometimes very noticeably, and there's absolutely no downside of using resource hints, especially for fonts. So I already talked a little bit about, prefetching. So prefetching is when you have links in your viewport and you download them, and then when your browser will cache them, and then when you click on them, they load instantaneously. As I stated before, like Gatsby does this right out of the box. Gatsby is like a fantastic system that does this. But if you're looking for something that like integrates directly within Drupal, check out Quicklink. Quicklink is a module that I wrote. It uses a library that Quicklink uses a library that Adi Asmani at Google wrote, and what it does is it will download items that enter the viewport, and I'll show this to you in action right here. It's pretty neat. So if you download and install Quicklink, it will work right out of the box. It does like a lot of cool things where it works with like Drupal behaviors. It will not prefetch if you're authenticated. It will not prefetch if you have sessions. Andy submitted that patch. Thank you, Andy. And a lot of cool things like that. So what you're going to see like right here is as I scroll down and hyperlinks enter the viewport, the browser is going to start downloading stuff. I'm going to uncheck this disable cache right here so I can show you how some of this works. So I'm going to scroll down, and things are going to enter the viewport, and you can see as things enter the viewport, it's downloading these documents right here, which is pretty cool. So now, like you can see, like so I have this link right here for kick-ass visual regressions with Tugboat, and when I click on this, it loads instantaneously, and you can look at the HTML right here, and it doesn't download. It loads in 10 milliseconds because it's fetching it from the browser's cache as opposed to reaching out to our server. Kind of cool, right? Yeah, kind of neat. And then, like, of course, as I scroll down, it will re-download more stuff, and it'll just kind of work. So I have like 7 minutes. So the critical path is something that's very important to kind of grab your head around. The critical path is everything that blocks rendering. And what you want to do is you only want to put stuff in the critical path that belongs in the critical path. If you put things in the critical path that don't belong there, it's going to delay rendering for no good reason. So a couple things that I have seen that people do it. Have you ever like written CSS and you like maybe like base64 encode an image and throw it in your CSS background image property and stuff? And it's cool because it kind of saves like an HTTP request, but it's kind of like a little bit anti-pattern because you're actually taking an asset that is not render blocking, you're making it render blocking. And it takes a little bit longer to load, it takes longer for the browser to parse that. That's something to keep in mind. You want to kind of take all your JavaScript that you have in the head of your document as much as possible, put it into the footer of your document. That will make sure it is not render blocking. It will get that first paint out there first. And componentize your CSS. You know, load as little CSS as you need. I talked a little bit about compositing earlier. Remember when I said like, you know, the difference between compositing and painting and layout? You know, just as a refresher, your browser will do the layout operation, which is like figuring where stuff goes out on the page. That's a very expensive operation. After it does that, it does painting. It starts like putting like colors on the page. And then if you have multiple layers of that, it does a compositing. And the compositing is where it just combines the layers. Now you want to, when you're doing animations, you want to only do the animate. You want to focus on compositing as opposed. You want to avoid like repaints and things like that. So some common things I've seen people do that cause repaints are animating properties like background position or the top left, bottom, like there's absolute positioning stuff, margins, padding, heights and width. All those will cause repaints as your browser's kind of doing things. What you want to do is the two safest CSS properties to animate are transforms, and with CSS transforms you can do a whole bunch of things. You can rotate, you can do scale, you can do translate where you move it up and left. So if you're moving stuff around, you want to use the transform, translate Y, translate X, things like that. Something else that's fairly performant is animating opacity, as opposed to like animating, say, like a background color. Animating opacity is very performant. We want to, of course, avoid inlining images in via base64 encoding, and you want to avoid large style sheets. I'm a big fan of componentization. Like Drupal 8's library system is pretty cool, where you can create a CSS file individually for every component, and then what you can do is you can like use like something like the twig attach library function and throw that directly in the top of your twig file, and whenever that twig file is called, it'll just ensure that that CSS file is loaded. It makes it pretty easy, but you still have to kind of do it. You want to split up those monolithic style sheets as much as possible. There's a coverage tool within Chrome that can help you identify your unused CSS. And I'm going to show you where that is, but I'm not going to run it. But like what you can do is you can hit the, let me do it this way. I'm going to open up the show console drawer, and then if you click here, like it's coverage right here, but that's not visible by default. You can go to coverage. And when you hit coverage, you can hit record. And you can start like scrolling around and doing stuff up here. And you can even click and see all that stuff. And then when you hit stop, it'll actually tell you what percentage of your style sheets are being used. You can see like our main style sheet right here isn't only like maybe like I don't know, what is that, like 20% of it's actually being used, which isn't the best. Optimizing your JavaScript. This is the biggest thing. JavaScript's JavaScript is the most expensive thing that you can like really ship to your browser because the browser has to parse it, then it has to execute it. JavaScript works in one thread, so this is like an actual like microscopic image of the JavaScript working in the processor. Whereas like you have all your different cores working, and then you're just one guy doing the work. JavaScript processing times. It takes like I have a pretty fancy phone. It's a Pixel 2. A lot of us web developers have fancy phones, but most people don't have fancy phones. And look at the difference between say an iPhone 8 and this like average phone for 2018, the Moto G4. Like that's like a 3 to 4 times right there. That's something that people notice on their phones. That's why when you're doing these profiling, you want to slow down your CPU. I have just a couple minutes right here. I'm going to show one thing. I'm going to concentrate on third-party scripts. A lot of people have third-party scripts on their website. A lot of these are tracking scripts and things like that. And I'm gonna show how to identify these third-party scripts and hopefully show you exactly like how long they take. Has anyone used web page test before? Yeah, web page test is a free open source tool. It's online, and it's one of the best resources for actually profiling the front end performance of your website. So what we're going to do in this particular case is we're actually going to profile my hometown newspaper, which is Gainesville.com, and we're going to do it with and without third-party scripts. And so what I'm doing right here is I type in the domain name up there, and you can set your number of tests to run. I always go as much as possible to 9. And what it will do is it will hit that multiple times and kind of like use the median average, right, or the median value for that. And I also check this option right here for capture video, because what we're going to do is we're going to generate a side-by-side video with third-party scripts and without third-party scripts, and then just give it a label. So after that generates right here, it's going to give you a score, So all right. But what we're going to do is we're going to go back to the home page up here. So we're just going to click on home. And then we're basically going to hit this web page and say again, but we're going to do it without third-party scripts. So in order to do that, we're going to create a label. We're going to change the label right here. It says without third-party scripts, and we leave that capture video checked, and then we go to the script tag right there. And we're pasting in this script right here, and it says block domains accept. And there's a couple domains listed here, and they're space separated. And what they do is it's only going to allow these domains to pass through, and then it's going to navigate to that website. So we're going to paste that in right here, and then we're going to hit Start Test. And when Start Test is done, it's going to do the same exact thing. It's going to say, all right, well, here's your results. But then the magic happens. We go to the Test History tab at the top up here, and we click on this. And on the Test History tab, it's going to show what we just ran, and we check the box for each of these. So let me see. I'm going to check a box right here, and then I'm going to hit that Compare button to the top. All right, so I'm going to hit Compare. And it's going to give you this cool little thing, and it has like a little slider at the bottom where you can actually look at the difference in your waterfall. But what I'm going to do is I'm going to check this box right here. You can see there's the difference in the waterfall. But what I'm going to do is I'm going to check that button right there that says Create Video. And when I create the video, it's going to say your video is going to be available shortly, and then it's going to generate something like this, and it's kind of cool. So you can see I have one without third-party scripts and one with third-party scripts. In this particular case, it's kind of weird that the with third-party scripts actually finishes 0.3 seconds early, but it's an interesting thing to look at. And so you can actually take this video to your marketing communications department and say, listen, your third-party scripts are causing, maybe 2 seconds of slowdown here. We know that these 2 seconds of slowdown hurt our conversions. So, is it really is it really worth it? I'm going to show one more thing, just because I'm gonna go a little over because this is super important. It was Chattanooga Times. Is that what the website?
Times Free Press.
Free Press. I'm gonna do one more profile of this, and then we're gonna look at third-party scripts. So we're going to do this a little bit different right here. I'm just going to go ahead and go to the Performance tab, and I'm just going to hit the Start Profiling and Reload. And I'm just going to let it go for a couple seconds because we don't have a heck of a lot of time. I'm looking for my water here. And I'm going to show you how to look at third-party scripts right here. So you can see we have a whole bunch of third-party scripts coming in. Now what I'm going to do is I'm going to go to the bottom up tab down here, and by default the bottom up tab has no grouping, and you can see what's taking up a lot of time. But what I'm going to do is I'm going to group by subdomain. And when you group by subdomain, you can actually see that Google Tag Services is using over a half a second, DoubleClick is using another half a second, Ajax Google APIs is using 400 milliseconds, and you can kind of start seeing what these third-party scripts are actually using right here. And you can honestly also group by product. Google Chrome Developer Tools can is intelligent enough to identify systems like DoubleClick or things like that. And so you can kind of see this blueconic.net is using 300 milliseconds of processing time here. So that's something to keep in mind right there as you're looking at your third-party scripts. I'm a big believer in an open web as opposed to proprietary solutions. In order for the open web to win, it needs to be performant. It needs to be good to use. It needs to be fast. And yeah, thank you.